In this video, we will continue practicing solving quadratic inequalities such as this one. Our strategy is to start by solving the related equation x squared plus x minus 6 equals 0. We can solve this probably by factoring. X squared can only be x times x. 6 is either going to be 2 times 3 or 1 times 6. Inner plus outer must equal middle. Inner I have 2x, outer I have 3x. The middle has to be 1. So if this is a negative 2 and a positive 3, that will give me 1x for the middle. So there's my negative 2, and this will give me positive 3. And negative 2 times positive 3 is negative 6. So we have factored it correctly. So we can finish solving this equation by setting these factors equal to 0. So x minus 2 equals 0, x plus 3 equals 0. That gives me the two solutions, x equals 2 and x equals negative 3. So these are the two places where the function equals 0. So the function equals 0 at 2. So I'm going to put a closed circle there. The function equals 0 at negative 3. So I'm going to put a closed circle there. I'm making these closed circles instead of open circles because the solutions to this inequality are the points where the function is less than or equal to 0. These are the places where the function is equal to 0, so they should definitely be included as solutions. If this had just been a less than sign, I would have left these as open circles. All right? Now, these endpoints, these zeros, divide the number line into 3 intervals. We will check each one of these intervals using a test value. We're going to pick a test value from each interval and find out if there are solutions in these intervals to this inequality. So we need to pick a value that is less than negative 3. So how about negative 4? So let's check the value of the function at negative 4. And we're checking to see, is it less than or equal to 0? Okay, we need to pick a value in this interval. And 0, I always like to use 0 when it's in the interval. And we're checking to see, is the function less than or equal to 0 there? And then finally, we'll pick a value that is greater than 2. So for example, 3. And we'll test the value of the function at 3 to see if the function is less than or equal to 0 there. We're going to use our TI-30XS multiview to make this process go faster. So go ahead and enter the left part of the inequality, x squared plus x minus 6. So x squared plus x minus 6. And hit enter. Make sure your calculator is in Ask X mode. It will be ever so convenient. So we want to test the function at these 3 specific values, negative 4, 0, and 3. So we can just type them in, negative 4, 0, and 3. So this is what we get, 6, negative 6, and 6. Okay, so I got 6, negative 6, and 6. So we are asking ourselves, is the function less than or equal to 0 here? Okay, let's see. Is 6 less than or equal to 0? No. All right, that means negative 4 is not a solution, which means none of these values over here in the first interval are solutions. So we will just leave this blank. Is negative 6 less than or equal to 0? Yes, it is less than 0. That means 0 is a solution. which means that every point in this interval will be a solution. And we will show that by drawing a segment here. And we already said that 6 is not less than or equal to 0. So that means 3 is not a solution either, which means that none of the values in this interval will be solutions. So we will leave this space blank. So this is the graph of our solution set, and we can easily translate that into interval notation. Our solutions are from -3 to +2, including -3 and +2. So we will use brackets to show that these endpoints are included as part of the solution set. So that is it for number 4. All right, let's keep going and do a couple more problems. Okay, number 5. So let's start by finding the zeros of this part of the function. So we will solve the related equation x squared plus 6x plus 9 equals 0. And we can probably solve this equation by factoring. X squared will factor as x times x. 9 is either going to be 3 times 3 or 1 times 9. We'll start with 3 times 3. Inner plus outer must equal middle. Inner, I have 3x. Outer, I have 3x. To get a middle of 6x, I need both of these to be positive, which means both of these would be positive, which works out because +3 times +3 is 9. So now we have factored the trinomial correctly. So we can finish solving the equation by setting these factors equal to 0. X plus 3 equals 0. There's no point in writing it twice because it's just going to be the same thing. So x plus 3 equals 0. If I solve this by subtracting 3 from both sides, I get x equals -3. Okay, so this only has one solution, x equals -3. Let's go ahead and graph that. So -3 is right here. I'm going to put an open circle this time. The function equals 0 at -3. But the solutions to this inequality are going to be values where the function is less than 0, not equal to. So we don't want to include this endpoint. That's why I make it an open circle. If this had said less than or equal to 0, then I would have included this point by making it a closed circle. Okay, so this single value divides the number line into two intervals, less than -3 and greater than -3. So we are going to do two test values, one in each interval. So let's pick a test value less than -3. So for example, -4. So let's see what is the value of the function at -4. And specifically, is it less than 0? All right, because that would make it a solution. And let's test, let's pick a value in this interval that's greater than -3. I always use 0, okay, when it's in the interval. So I will test the value of the function at 0. And again, is that going to be less than 0? That would make it a solution. I am going to use my calculator, my TI-30XS multi-view, to make this go faster. So type in the left side of your inequality, x squared plus 6x plus 9. X squared plus 6x plus 9. Enter. Make sure your calculator is in Ask X mode. Enter, 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 enter. Okay. Now, we are interested in the value of the function at these two values, -4 and 0. So it's funny because I already have -4 and 0 here, but if you didn't, you would just type in -4 and you would type in 0. Now I'm just going to delete this one because I don't need it. So these are the values that I get. At -4, we are, the value is 1, and at 0, the value is 9. Okay, so what was that again? 1 and 9. So I got 1 and I got 9. So the question is this less than 0? And is this less than 0? And the answer in both cases is no. That is not less than 0. And no, that is not less than 0 either. Okay, so we have no solutions to the left, and we have no solutions to the right. -4 is not a solution, which means none of these are solutions. 0 is not a solution, which means none of these are going to be solutions either. Okay, and even this point, the -3 is not a solution because the function equals 0 here. So that means we have no solution. All right, so this inequality has no solution. All right, this will be the last problem that we're going to do. So once again, we're going to solve this inequality by starting with the related equation, x squared plus 20x plus 100 equals 0. And we can probably solve this by factoring. Okay, so we're going to factor this down. And so x squared will only factor as x times x. All right, 100 is many things, but one thing that will give you 100 is 10 times 10. And inner plus outer equals middle. So inner, I have 10x. Outer, I have 10x. To get a middle of positive 20, then I need both of these to be positive. So that means these would both be positive, which works out great because positive 10 times positive 10 is positive 100. Okay, so we have factored correctly. So to finish solving this equation, I would set the factors equal to 0. Since they are both the same, I'm not going to do it twice. I'm just going to say x plus 10 is equal to 0. Subtracting 10 from both sides gives us x equals -10. Okay, so I'm going to plot -10 on this number line. Or am I? Because -10 doesn't fit on this number line. All right, I'm going to have to throw out this number line. That number line was not big enough to contain -10. So I'm just going to draw my own number line instead. Okay, so here is 0, and here is -10 over here. So there's my number line. And so I'm going to go ahead and put -10. I'm going to put an open circle at -10. I'm putting an open circle because the solutions to this inequality will be the places where the function is greater than 0. -10 is a place where the function is equal to 0, not greater than 0. So this endpoint is not to be included as part of the solution set. Okay, so now this endpoint has, this 0 has divided the number line into two intervals, values that are less than -10 and values that are greater than -10. So I am going to pick a test value in each interval to see whether or not there are solutions there. So I need to pick a value that is less than -10. For example, -11. And I want to see, is the function greater than 0 there? And then I'm going to pick a value to the right, greater than -10. 0 is a good one to use here. And I want to see, is the function greater than 0 here? So I'm going to use my TI-30XS multi-view to make this process go faster. So go ahead and type in the left side of your inequality, x squared plus 20x plus 100. Okay, x squared plus 20x plus 100. And make sure your calculator is in Ask X mode for maximum convenience. Just hitting enter a few times. Now I specifically want to know the value of the function at -11 and 0. So I'm just going to type in -11, and 0 is already there. But so these are the values, 1 and 100. Okay, so I got 1 and 100. The question is, are these greater than 0? Is 1 greater than 0? Yes, it is. 1 is greater than 0. That means -11 is a solution, which means all of the points in this interval are solutions. So I'm going to show that by putting array there. Is 100 greater than 0? Well, yes, it is. That's also greater than 0. That means 0 is a solution, which means every point in this interval will be a solution. Okay, so this is a graph of the solution set. Now, how to write this in interval notation? Notice that we can't just say -infinity to +infinity, because there's one crucial value that is not a solution. -10 itself is an open circle, all right, because it's not a solution there. It's equal to 0 there, not greater than 0. So we will have to write two separate intervals. For the left ray, that goes from -infinity to -10. All right, and I'll put a parenthesis to show that -10 is not included, open circle. And then union, and then for the right ray, that's going to be from -10 to infinity. -10 to infinity. And that's it. That's the solution to number 6, and that's going to do it for this video. I hope it was helpful, and I will see you on the next video.